Let us see, students, the nth term of the arithmetic progression. Here we are considering one example to get the general form of the nth term of a arithmetic progression. Let us consider the offer to Usha, who applied for a job and got selected. She has been offered a starting monthly salary of rupees 8,000 with an annual increment of rupees 500. Now, what would be her monthly salary of the fifth year? Okay. To answer this, let us first see her monthly salary for the second year would be rupees 8,000 plus 500. That is equal to 8,500. In the same way, we can find the monthly salary for the third year, fourth year, and fifth year by adding 500 salary of the previous year. So, the third year is equal to rupees 8,500 plus 500, and then 8,000 plus 500 plus 500, that can be written as 8,000 plus 500 plus 500, and then 8,000 plus the two 500s are can be written as 2 into 500, and 8,000 plus the 2 can be written as 3 minus 1 into 500. That is, anyhow we get 9,000 only. So children, see the first salary for the fourth year, rupees 9,000 plus 500. Then next, that 9,000 can be written as 8,000 plus 500 plus 500 plus 500. So here again 8,000 plus 3 into 500, and next the 3 can be written as, that means 8,000 plus the 3 can be written as 4 minus 1 into 500. So anyhow we get 9,500. And next, in the fifth year, obviously we get 9,500 plus 500. Why? Because we are adding the 500 to the previous year's salary. So that can be written as 8,000 plus 500 plus 500 plus 500 plus 500. That means after 8,000 we get 4 500s obviously. The next, that can be written as 8,000 plus 4 into 500. Then that 4 can be written as 5 minus 1. That means 8,000 plus 5 minus 1 into 500. So see the process carefully. So what I am writing one by one. So now obviously 10,000 we get. Next, so observe that we are all getting the list of numbers: 8,000, 8,500, 9,000, 9,500, 10,000, up to so on. Obviously these are all in which arithmetic progression. Okay. Next, looking at the pattern above, we can find the salary in the sixth year and also in 15th year, assuming that he is still working in the same job. So what would be her monthly salary in the previous year? Can we make this process shortest? Let us see. You may have already got some idea from the way we have obtained the salaries above. So what about the salary of 15th year here? So the salary of the 15th year is simply salary for the 14th year plus 500. That the salary of 14th year can be written as 8,000 plus 500 plus 500 plus 500 up to so on 500. Obviously that increment plus 500. Here 500s are repeated in how many times? Simply 14 times. That is 8,000 plus 14 into 500. So overall we can get 8,000 plus that 14 can be written as 15 minus 1 into 500. So obviously we get 15,000. That means first salary plus 15 minus 1 into annual increment. In the same way, her monthly salary for the 25th year would be 8,000 plus 25 minus 1 into 500 is equal to 20,000. So we also find her salary if we continuous in the job. We can find 30th year or 33rd year also. Okay, like this we can find. Now her salary in 20th year is first salary plus simply 25 minus 1 into annual increment. So these examples has given us an idea about how to write the 15th term or the 25th term by using the same idea. Now let us find the nth term of an AP. Okay, now let A1, A2, A3 up to so on be an AP whose first term A1 is A and the common difference is D. Then the second term A2 is equal to, obviously we know that A plus D. So A plus D nothing but we can write that D quotient is taken as 1, then we can write A plus 2 minus 1 into D, 2 minus 1 times of D. And similarly in third term, A3 is equal to A2 plus D, that is that A2 nothing but here A plus D, that is equal to A plus 2D, that is equal to A plus 3 minus 1 into D. See the process, children, see the pattern what I am writing. And next the fourth term A4 is equal to A3 plus D, obviously that A3 nothing but what, actually A plus 2D. So we are adding again the same fixed quantity, that is D, that is plus D. Then we get A plus 2D plus D, that is equal to A plus 3D, and again A plus 3D can be written as A plus 4 minus 1 into D. So up to so on. Looking at the pattern, we can say that the nth term an is equal to a plus n minus 1 into d. Okay, so like this we will generalize the term. So the nth term of an AP with the first term and common difference as d is given by a is equal to a plus n minus 1 into d. So this is how do we get the general term of the AP by taking a regular and good example, that is the salary of that Usha. Okay, her first monthly salary is 8,000 and her every annual increment is 500. By using that live example, we can easily understand how to give the AN in general form. So if you understand this process, you cannot be forget the formula and the pattern of the AP, that is the arithmetic progression. How do we write the pattern of the arithmetic progression? How do we can write the arithmetic progression in general sums? So this idea is useful in many types of sums. Okay, now here again let us see the another concept. Now let us see some examples. So first find the 10th term of AP, 5, 1, minus 3, minus 7 up to so on. Solution. Here A is equal to 5, D is equal to 1 minus 5, that is equal to minus 4, and N is equal to 10. We have AN is equal to A plus N minus 1 into D. And next, A10 is equal to 5 plus, as we know n value 10, so substitute 10 minus 1, D value minus 4, that is substituted. Then we get 5 minus 36 equal to minus 31. Therefore, the 10th term of the AP is minus 31. Next, which term of AP is 21, 18, 15 up to so on is minus 81? Children, these are very important sums for 2 marks, so listen carefully and do practice well. Next, here A is equal to 21, D is equal to 18 minus 21 is equal to minus 3. And then if AN is equal to minus 81, we have to find AN is equal to A plus N minus 1 into D. Then minus 81 is equal to 21 plus N minus 1 into minus 3. So minus 81 is equal to 24 minus 3n. So minus 105 minus 81, take the 21 left side, we get the minus 81 minus 24 is equal to minus 105 is equal to minus 3n. Then n is equal to 35. Next, therefore 35th term of the given AP is minus 81. So like this we will ask for the 2 marks. Now we want to know if there is any n for which n is equal to 0. If such n is there, then (21 plus n minus 1 into minus 3 equal to 0). That is 3 into n minus 1 is equal to 21. Then n minus 1 is equal to 7. Then n is equal to 8. That means here eighth term is the next. Sum of first n terms in the arithmetic progression, the next concept, children. Now it is also understand by using some our daily life example. Now see that. Let us consider the situation. Hema put rupees 1000 in money box when her daughter was 1 year old, and rupees 1500 on her second birthday, and rupees 2000 on her third birthday, and will continue in the same way. How much money will he collected in the money box by time her daughter 21 years old? So here the amount of money put in the money box on her first, second, third, fourth, up to so on her birthdays respectively, 1000, 1500, 2000, 2500, up to so on till her 21st birthday. To find the total amount in the box on her 21st birthday, we will have to write each of the 21 members in the list above and then add them up. So don't you think it would be tedious and time-consuming process? Can we make the process shorter? Let us see. So now students, let us continue to find out the sum of first n terms in arithmetic progression. So here one situation we have. So here this mathematics scientist, German mathematician Gauss found the sum of these terms. So how Gauss found this sum of n terms? So let us consider one situation here. So we consider the problem given to Gauss to solve when he was just 10 years old. He was asked to find the sum of the positive integers from 1 to 100. So he replied that the sum is 50-50, that is 5050. So how can you guess how could he do it? So let us do that one. So first let us suppose n is equal to s is equal. Let us suppose that s is equal to 1 plus 2 plus 3 plus up to so on 99 plus 100. Add, then reversed the numbers to write s is equal to 100 plus 99 plus up to so on 3 plus 2 plus 1. So when he added these two term by term, then he get s plus s to s, 100 plus 1, 99 plus 2, and obviously we get here 98, so 98 plus 3. So like that up to so on, again here 99 plus 2, and here 100 plus 1. So like this adding, we get 100 plus 1, 101 plus 101, and again 101 up to so on. Here also 101, the last also 101. So here actually 101 is repeated how many times? As you know, it is simply 100 times. Okay, why? Because we are taking only 100 numbers. Okay, now 2s is equal to, we can write 101 is repeated 100 times, means the sum of those 101s is simply 100 into 101. Then s is equal to 100 by 2 into 101. So by cancellation, s is equal to 50 into 101 So we get 5050. Therefore, the sum of first 100 natural numbers is 5050. So like this, Gauss found out sum of these 100 natural numbers in this way. So now let us discuss how can we find sum of n terms in this pattern only. By using this idea only, we have to find the sum of the n terms in arithmetic progression. So we will now use the same technique here. I said no, that only that was used by the Gauss. So first let us write down to find sum of n terms in AP. So let us start by taking the terms in AP. In AP we have in general A plus D, A plus 2D, up to so on the nth term, as we know already, A plus n minus 1 into D. So let it be taken as some Sn. Okay. Now, by taking reversing order of this pattern, that is this sum in the reversing order, first to add these terms. First add this term Sn plus in the straight order. Sn is equal to A plus D plus A plus 2D up to so on, plus A plus n minus 1 to D. Then take the same sum in reverse order. So then we get here simply A plus n minus 1 into D, and again A plus, this before term is, we can write A plus n minus 2 into D. Why? Because we have actually at here A plus n minus 1 into D, and the before term easily we can write A plus n minus 1 minus 1, that is n minus 2 into D. So, but whereas in reversing order, first we have to write A plus n minus 1 to D, plus the next is A plus n minus 2 into D, up to so on. Here again we get the same numbers which are the last term, A plus, A only, that reverse of this last term is A, or otherwise we can write A plus D plus A, that's before term also. Now by adding these two by term, A plus A n minus 1 to D, and again A plus D. By term, we should add by term A plus D plus A plus n minus 2 into D. So up to so on. Here also we get A plus n minus 2 into D plus these two terms plus A plus D, and the last A plus n minus 1 to D plus A. You just children observe each and every term is become 2A plus n minus 1 into D, plus here also A plus A 2A. Here D is common both of these, so we can write D into 1 plus n minus 2 plus up to so on, and here also A plus A 2A, and again here D common, we get n minus 2 plus 1, and here A plus A 2A n minus 1 into D. So by assuming all these, we get simply 2A plus n minus 1 into D in all the term by term sum. So 2A plus D into n minus 1 or n minus 1 into D, we can write it as n minus 1 into D up to so on. Here also we get 2A plus n minus 1 into D. So here again these terms are repeated n times. Why? Because we are taking n terms, so these are all n times. So 2Sn is equal to, we can write n into 2a plus n minus 1 into d. Therefore, the Sn is, sum of these n terms is n by 2 into 2a plus n minus 1 into d. So like this, we can obtain the sum of the n terms of the AP. Okay. Now let us do some examples on this. Okay. A manufacturer of TV sets produced 500 sets in the third year and 700 sets in the seventh year. Assuming that the production increases uniformly by fixed number every year, find the production in 15th year and the total production in first 10 years. So here students, so while understanding the sum, since the production increases uniformly by a fixed number every year, the number of TV sets manufactured first, second, third, up to so on years will be form an AP. Okay, by this understanding the sum, we can write this one. Now let us denote the number of TV sets manufactured year by A. Then that which one 500 sets in the third year, that is you can write A3 is equal to 500, and similar way 7th year 700, that is A7 is equal to 700. So by writing the A3 formula, you can write A plus 2D is equal to 500, and similarly A7 is equal to A plus 60, that is equal to 700. So here used formula is AN is equal to A plus N minus 1 into D. Now solving these two equations, A plus 2D equal to 500, so equation 1, and A plus 6D is equal to 700, so equation 2. So by subtracting, we get simply minus 4D is equal to minus 200 by elimination method, as we know. So minus 200 by minus 4, simply we get D value 50. Now substitute D value 50 in equation 1. Okay. A plus 2D equal to 500. A plus 2D equal to 500. So A plus 2 into 50 equal to 500. A plus 2 plus 50 is 100 is equal to 500. A is equal to 500 minus 100, that is 400. That is here A nothing but A1 only. So in first year the TV sets are manufactured, the number of TV sets are manufactured 400. Okay, now here we need to find in 15th year. So A15, that is A plus 14D, as we know that one. So A value 400 and D value is 50. Substitute them. 400 plus 14 into 50, then we get 400 plus 700, 14 5 is 70, 70, so 14 50s are 700. So simply we now 400 plus 700, 1100. Now on continuation we need to get the total production in 10 years. So for that we need sum of the n terms. Just we solve that formula by the method of by taking the Gauss technique. So that Sn formula is n by 2 into 2a plus n minus 1 into d. As we know, here A is first term, D is common difference, and n is the number of terms. So here we need to get 10 years. So for 10 years the total TV sets manufactured in 10 years. So that's why we are taking n is equal to 10 and A is equal to, we have 400 and D is equal to 50. Substitute one by one. First of all substitute 10. So 10 by 2 into 2 into 400 plus 10 minus 1 into 50. So by cancellation we get simply 5. So we got it is 800. 9 into 50, so 5 into 800 plus 450, then 5 into we get 1250. So on multiplication we get simply 125 is a 625, that is 6250, that is totally 6250 TV sets are manufactured up to in 10 years. So like this way we should use this formula. Okay, one more sum important is there, let us discuss. These are all for 4 marks, so we practice well. Okay, and the next and 17 terms, and that of 17 terms is 289. So find the sum of first n terms. Sum of n terms, first n terms. So here in AP we have the Sn formulas. Sum of n terms, Sn is equal to, again I am writing n by 2 into 2a plus n minus 1 into d. So first we have sum of 7 terms is 49, that is S7 is equal to 49. So substitute here 7 by 2, we don't know A and D, that only we need to find by using the given information. So 2a plus 7 minus 1 into d is equal to 49. Take the 7 by 2 on right side. 2a plus 6d is equal to 49 into 2 by 7. By cancellation we get 2a plus 6d is equal to 14. So equation. In the same way, find S17. We have here 289. Then same formula, by applying S17 is equal to, we get 17 by 2, 2a plus 17 minus 1 into d is equal to 289. Then 2a plus 16d is equal to 289 into 2 by 17. So by cancellation we get 17. 17 is 289 as we know. So 2a plus 16d is equal to 34. So by solving 1 and 2, we get 2a plus 6d is equal to 14. We get a and d values. So that's why we are solving these two by elimination method again. So here 2a same, that's why we can subtract these two. 2a gets cancelled. 6 minus 16d minus 10d is equal to 14 minus 34 minus 20. Then d is equal to minus 20 by minus 10. Then we get d value 2. So now, so let me finish here. So substitute d is equal to 2 in equation 1. So 2a plus 6d is equal to 14. So 2a plus 6 into 2 is equal to 14. Then 2a plus 12 is equal to 14. And then 2a is equal to 14 minus 12. 2a is equal to, simply we get 2. Then a is equal to 2 by 2, that is 1. So a value 1 and d value 2. Now we need to find Sn, that is by using again the Sn formula, we have to find the first n terms of this AP. Again I am writing Sn is equal to n by 2 into 2a plus n minus 1 into d. So here a value is 1 and d value is 2. Now substitute Sn is equal to n by 2 into 1 plus n minus 1 into 2. So n by 2 into 2 plus 2n minus 2. 2 gets cancelled. We get n by 2 into 2n. 2 gets cancelled. We get n square. So children, once you observe the data, here verification, just our answer is correct or not, verify ourselves. By which way? We have S7 is equal to 49, that is 7 square. And again immediately what we get S17, what we have S17 is equal to 289, that is 17 square. That means here also we got Sn is equal to n square. That means the sum of the 7 terms in this particular provision is 7 square. Sum of the 17 terms is 17 square. So then obviously sum of those n terms is n square. So like this we can verify the answer. Thank you.